Okay, kids, this is still about forces, but this time we're going to focus more on the sizes and also the directions of this so-called force. Now, before we move further, I want you to look at what we need to know on today's session. All right? What we are going to look for are the sum of forces, sizes, speed, direction, force meter, and there's another new one here, Newton. At the near end of our lesson, you should be able to tell the relationship between the sum of forces and the speed of the objects. Okay, let's start with the direction. Okay, I have here two boxes for you. And say I want these boxes to be moved to the right. What are we going to do with these boxes? One thing that we can do is to exert a force in that direction. And another thing, you can position yourself here and tie a string there and exert the force in that same direction. Now, last session we studied the two types of forces. This is actually a push and this one is a pull. Both of these activities can move the boxes to the right. What if we want this to be moved to the left instead? Our first guy here can just go to this side and push it in the opposite way. For our other guy, he can just move to the other side and do the same thing. Pull the cart using a rope, but in the opposite direction. Now how about the sizes? I am going to give you here a device that is actually found in our science laboratory. It looks like this. There are some lines like that, like what you are always been seeing in your rulers. And on top of those lines, you will be having some numbers and some letters. Now, there's also this arrow, or sometimes they call this a pointer, that tells us the value of one particular force. For example, if you want to exert a force in there, the pointer is going to be moved somewhere, depending on the amount of force you exerted at that hook. Whatever number the pointer will be pointing at is going to be the value or the amount of force. This is actually how strong or weak the force being exerted is. And this one, kids, is the so-called size of force. By the way, this device that tells us the size of force is called force meter. And as you can see, there are some letters in there. The letter N stands for Newton. Newton is a unit of force. The same idea as when you are telling the time, like 30 seconds or 1 hour. The second and the hour there are actually units of time. Or another example is distance. When you say distance, you can just say 50 meters. The meter there is actually a unit of distance. When it comes to forces, the unit is Newton. The symbol for Newton is N. Let's have some practice in here when it comes to sizes and direction of forces. But before that, I want to go back to your simulation first. Alright. Now in this case, there are no forces. So the object at the middle is not moving. I'll be asking this guy to position himself there. And later he will be exerting a force amounting to 100 Newton. This is the size, kids. And the arrow is pointing the direction. Now, at the other side, I will ask this boy to position himself there and another boy to position himself there. Both of them have 50 Newton and when combined it's going to be 100 Newton as well. Now the sum of forces is 0 because they just cancel each other out. If you want to see the effect of this one, we click on go. Though there are forces, the forces just cancel each other. Okay, let's return. How about if I ask this guy to go back? The 100 Newton force leftward of this guy being reduced by the 50 Newton force rightward of this guy. That's why the sum of forces here is 50 Newton. What will happen if this is the case? We click go and then you will see the cart will be moved to the left, to the direction of the sum of forces. Alright, how about if I ask this guy to go there? The sum of forces points to the other direction. The reason is the rightward force is greater than the leftward force by 50 Newton. Click go and you will see that this time the cart is moving to the right, to the direction of the sum of forces. Pause and then return. Let's go back now to my previous slide. Alright, say I have a box there and there's a force here, there's another force here. Let's assume that this one is 20 newtons and the other one is 30 newtons. What will happen when you combine this? What is the sum of forces? Yes, it is equal to 10 newton rightward. And what does this tell us? It tells us that the object will move to the right. Now let's have another scenario here. The same box, but this time I'm going to switch the values. Now what is the sum of forces? The size remains the same, 10 newton, but the direction is leftward. What does this tell us? The object will move now to the left. Right, before I proceed, I want to clarify something. I've always been saying some, but if you're going to look at it, this 10 newton came from 30 newton and 20 newton. It is more like a difference rather than a sum. Okay, there's no confusion here, guys, because what we are actually combining is not just the size, but we also consider the direction. All right? If the directions are opposite to each other, they tend to cancel each other out depending on the size. In this case, if you have 20 newton to the right, that 20 newton will cancel the 20 newton from here. So those 20 newtons are out. The only one remaining is the 10 newton, which is leftward. I hope that clarifies the idea. And let's go and compare the two results that we have. Alright, this was the first and this was the second. As you can see, one was able to move the object to the right and the other sum of forces moved the object to the left. Now, what can we see from here? What would be our conclusion from here? The idea is that the direction of the sum of forces will actually tell us to which direction the object will move. This is rightward and the object moved to the right. This is leftward and the object moved to the left. Another thing that we can get, not from the examples here, but from the simulation is that if you have a situation like this and you have another one there, instead of 30 newton we have, say 100 newton. And what is going to be the net force? Then it's 80 newton. It's still rightward, but this time it's stronger. This is 10 newton, this is 80 newton, and based from the simulation, you will see that this one is going to move faster. So what can we conclude from these two ideas? The larger the sum of forces, the greater the speed of the object. Right. Speed is the measure of how fast an object is moving. These are the ideas that you need to know for this week. After this, I'm going to entertain some of your questions. Before I forget, let me remind you that within this week also I'll be posting something in the Google Classroom which is related to our next topic about forces. You always stay healthy and safe. Stay at home.